Irodov problem number 1.235. A force F A I cap plus B j cap is applied to a point whose radius vector relative to the origin of coordinates O is equal to r equals small a I cap plus small b j cap, where small a, small b, a and b are constants and I, j are the unit vectors of the x and y axis. Find the moment n and the arm L of the force F relative to the point O. So force is given as, the vector force is A I cap plus B j cap, and this force is acting at a point whose radius vector is given as small a I cap plus small b j cap. Okay. The question is to find the moment of force n. Now, just a matter of notation, this n is nothing but the torque. Okay, I prefer to write it as tau. Okay. The other question is to find the arm L of the force about O. What this means is the perpendicular component of the radius vector. Okay, what do I mean by that? So, if the force is, let's say force vector is this, and this is the origin, and the radius vector of the point on which this force vector is acting is r. Okay. So obviously the torque will be what? If the radius vector makes an angle theta with F, and if I take my right hand, I know the image will be flipped. If I take my right hand and move it from R towards F, the thumb, the direction of the thumb gives me the direction of the torque. So in this case the thumb is moving. So in the video you will probably see this as my left hand, but this is my right hand. If I move from R to F, thumb is going in, so the direction of the torque is perpendicular to the board going out towards you. Okay, so that is the direction of the torque. But what is R perpendicular? This is O. So arm of F is, if I drop a perpendicular to this force F, okay, so this is perpendicular, and then if I also drop another perpendicular from O like this, so this part, this length is the arm of the force L. I also represent it as R perpendicular. Why? Because it is the component of R. If I make two components of the radius vector, one along this direction, another along this direction, the perpendicular component of R is the arm of the force about O. Okay, so that is what the question is asking. Now let's do the math. So tau is R cross F. Okay, it's a vector quantity, R cross F. Now R is given as A I cap plus small b j cap, and F is given as capital A I cap plus capital B j cap. Now how do we do the cross product? I usually write this out, I, j, k. If you multiply I to j, you will get k. If you multiply j2 with k, you will get I. If you go the other way around, which is I times k, then you will get minus j. If you go j times I, you will get minus k. Okay. So now let's do the multiplication then. So I cap I is 0, I cap times j cap, ij, so it will be k. So a, b, k cap. Similarly, b times, so b j cap times a I cap. So b a. Now j times I, so minus k cap, and j will be 0. So the value of tau is small a capital B minus small b capital A k cap. So obviously if ij are on the plane of the board, k cap is perpendicular to the plane of the board. Okay. Now what is r perpendicular? R perpendicular is, so this angle is theta, is r, the vector, the mod of r sine theta. Now mod of r we can find out. Mod r will be what? Root over small a square plus b square. This is easy. But how do we find out sine theta? So this is what I will do. Now tau, if I take mod of that, will be r, so mod r times mod f sine theta, cross product. So sine theta is mod tau divided by mod r times mod f. Okay. Now we'll substitute the values. Just give me a second. So coming back to this, so r perpendicular, or the arm that we are trying to find out, is mod r sine theta. So mod r sine theta is tau divided by mod r times mod f. I omitted the vector signs, but let's put that back in. So this and this gets cancelled. So this is mod tau divided by mod f. Now tau we already calculated. The value is AB minus BA, but I will take the modulus of it, or basically the positive value of it. Okay. Divided by mod f. Mod f is, again, it's easy. It will be root over a square plus b square. So this will be root over a square plus b square. So that's our answer. So this is the arm L of force about O, and the moment of force is tau, which is this. Okay.